Hello?
Yeah.
Hello? All right, cool. My homework finally loaded from my Gmail, so
Okay.
I shall bring it up if that's all right.
Yeah, sure.
All right, so let's see if I can share my screen. All right, cool. It should be loading right now. Hold on.
Okay.
Um, Question: how do you share your screen? I kind of
Oh,
forgot how to do it.
you see that arrow on the bottom?
I see.
Okay.
Okay, so
You click on
you said
that.
arrow on the bottom. It says share application screen, right?
That's right.
Awesome. Okay. Yes. All right. So, all right. Can you see my screen?
It's loading up.
Oh, take
Yes.
that. Lit. I take that as a yes. All right. Let me just bring up my files here. Excuse me for my slow computer.
So yeah, it's coming up, I think.
Thank you. Um. Hold on. I just downloaded. All right.
On it.
I guess I'll just do it from my email then.
Okay.
Let me know if you can see it. It's kind
Yes.
of like short, so
Yeah, I see it.
do you prefer it this way, or should I like download it?
No, this is good.
Okay,
This is good.
so
This is
I'll
my
work on my book then. I know. I'm just like using mine as a like a viewing because this is kind of small for me. So for my presentation, I'm going to be doing number 27 on homework 6, and I do believe isn't that the homework where it asks for the intercepts, right?
I have no
Yeah.
idea. Yeah.
So
You're the presenter.
oh
You
yeah, my fault. It's okay. Yeah, I got you. So the question was like find all the x-intercepts in the equation given. And the equation was y equals x to the third, yeah, x cubed minus x squared minus 6x. So first what I did is I factored out the extra x in all the variables. So for the second phase for number 27, as you can see, I took away x out of the equation, giving me y equals x parentheses x squared minus x minus 6. So right off the bat, I already marked one of my x-intercepts as x equals 0 because once you factor out x, that automatically counts as like an x-intercept in of its own. So afterwards, I factored out the inner equation of x squared minus x minus 6, and that gave me x minus 3 and x plus 2. So with that being said, I set both equal to 0, and for the other intercepts, I got x equals 3 and x equals -2. So for my x-intercepts that I got for the equation for number 27 was x equals 0, it's x equals 0, x equals 3, and x equals -2. Thank you. That was,
Okay, so this is to find the x-intercepts, right?
yes,
Okay, x-intercepts are points. You find the x value. What's the y value for each point? So x-intercept
0. Yeah, it's x. So each point is like, the first one is 0, is 0, yeah, it's 0 point, yeah, it's 0 comma 0. The second one is 3 comma 0, and the second one, and the third one is -2 comma 0 because they don't have a y value since they are x-intercepts.
Okay, those are x-intercepts. Great. What's the y-intercept?
The y-intercept, you didn't ask for the y-intercept. You just asked
Oh,
you
I
asked
see. This question did not ask for the y-intercept.
Yeah, they did not.
Okay.
That's homework 7 that you're thinking of.
I see. What if I ask you what's the y-intercept?
Oh, you said what if you asked me
Yeah,
what the y
if I'm asking you, right, what's the y-intercept for this one?
the y-intercept it's 0 because if you plug it in, because if you plug in 0 for each x variable, then you do not get a positive variable because you cannot multiply 0 and 0 and get a
That's good.
answer starting 0.
That's good. Also, y-intercept is also a point. What's
Yes,
the x value?
0. So the y-intercept
0.
would be what's up?
You're right. So what's the y-intercept?
The y-intercept
It's a point. Has x value, has a y value,
yes.
which
So
is
would 0 comma 0.
great. So you see,
0.
0 comma 0 is y-intercept, is also x-intercept.
Awesome.
Just
Oh
in this
yeah,
case,
that makes sense.
right? Okay, good. All right, good.
Would you like me to do another one?
For sure, of
Another
course.
presentation?
Yeah, but choose from different
Right.
homework,
You just
different concepts.
yeah, yeah, definitely. Let me just
Okay.
pull up my notes here. Let me just take a quick snapshot and then
Yeah, you
I
can
will
come
bring
back.
it up.
Right.
Up.
Right, you can come back. Okay, let's see. Oh, James. James.
Yeah, yeah.
Right, you can choose from different homework set. All right.
Mhm.
James, you already have. Let me see how many credits you have. You already have 5 credits.
As you should,
So
James.
choose something you haven't shown yet, just like this.
My
And also, Nikala, you
boy
have
James is smart out.
Nikala from a review sheet, right?
Mhm.
You can choose some questions. If you're not sure, we can go over. I can help you to make sure of it. But
Okay.
you can also earn your presentation credits.
Mhm. So wait, today we can present how many times until we get a perfect credit?
You could do that. Yeah,
Oh, okay.
you could try to do
Um,
that.
okay. I found one, but I'm not sure if you're going to accept it, so I'll just show my screen.
Okay.
So,
All right, my fault. Let me take my screen off
oh,
real quick because I realize I'm still on there.
mm, okay. So,
Is it gone?
yeah. Thanks, man.
All right, cool. Yeah, of course, bro.
Okay, so, homework 11. I'll be doing homework 11, the loss of logarithm, number 50. Is that good, Professor?
That's good. That's very good.
Okay. Oh, let's see where is it. Okay. Number 50, it says ln times a plus b plus ln times a minus b minus 2 ln c. This is a c, by the way. So as you can see, we have two laws of logarithm, which is plus and minus. In laws of logarithm, if it's plus, you're going to multiply it, and if it's minus, you're going to divide it. But in here, in the 2 ln uh, c, 2 will become an exponent. So our final answer should be ln times a plus b times a minus b all over c squared. So yeah.
Great. Great. That's it. Let's use the log property. Great.
Mhm.
Good job.
Oh,
Good
so
job.
that's for number 11. I'll
Yeah,
find another one, Professor.
but choose from different homework set.
Mm-hmm.
Great. You see how easy presentation could be?
Yeah, but it's just stressful.
It's just to show me, you understand, you know how to do the questions.
Mm-hmm.
Okay. You cannot, sure, of course, you can present on Friday. Jeremy already have full credits, no? Jeremy, oh, just missing one. Jeremy, do you like to present also?
Is it okay if I go after them?
Sure, of course.
Yeah, I'll go today.
Okay. I see
Yeah.
Andy's here too. Andy, do you like to present anything?
Who?
Andy?
I mean,
Okay,
if he's
anyway.
not, I got like a, yeah, I got a, what's it called? I think I'd like to present. That's all right.
Okay.
Yeah, I got
Yeah.
mine. So, this one is a little recent. This was, homework 15. Yeah, homework 15. I'll share my screen.
Okay. Yeah, just choose from different homework.
Yeah, I didn't do homework 15 yet. I didn't.
Yeah, I know. Good.
So, excuse me if this is a little, I mean, I like my what's it called? Strategies are a little shaky because I haven't done this. I haven't free balled this in a while, so like bear with me. So for I guess I'll, if you don't mind, I will review number 30. Wait. No, I'll review numbers 3 and 4. Sure,
3
number
and
3 and
4.
4. Yeah. Yeah, 3 and 4.
5.2 from 5.2.
Yeah, 5.2. Yeah, 5.2. Sorry, I didn't clarify. Um, yeah, I'll do those. So we got for number 3, we have sine of pi over 4, or pi, how, a quarter of pi, as I put it, and we have cosine quarter of pi. So for both, I said they were pi, well, square root of 2 over 2, because on a unit circle, whenever you have a quarter of pi, whether it be like 11 quarters of, well, yeah, well, whether it be like 11 pi over 4, or any time when pi is over 4, both coordinates are square root of 2 over 2, whether, but the only thing that differs is like the negative, like whether the coordinates are negative or positive depending on like the quadrant. So since pi over 4 is in the first quadrant, both coordinates will be positive. So for both, I put square root of 2 over 2. So yeah, that's like, sine of sine of pi over 4 is both, square root of 2 over 2. For number 3, we got the same thing, only difference is it's sine of, it's sine of pi over 6. Same thing with cosine. This one is different because now what's it called? On a pie graph, it's like what I usually do in order to like find out the angle. I set pi over 6 to a denominator of 180. Yeah, I set it to a denominator of 180. So normally what I get, I, get 30. Yeah, I get 30 as the angle. So as we know, since it's 30, it is the first equation that is touching, well, it's like the first equation going from the coordinates of one, yeah, one, yeah, 1, 0 to 0, 1. So that's like the first coordinate going to the left. So since we're doing sine, I believe, yeah, since we're doing sine, sine will always be, isn't that like the x coordinate, if I'm not mistaken, the x coordinate, because it's going from, yeah, it's the x coordinate. So another thing that I usually like, if you don't mind, I'm pulling up another piece of my evidence. This is like a little way I memorize the unit circle. Sorry if I'm
Okay.
going a little off topic, Professor.
No, it's great.
I
It's
figured
good to
this would be like
Okay.
really helpful to the class if it's like, if you
Yeah.
don't mind. Cool, cool. So if you just guys like will follow me here to this unit circle, this is like a nice little way that I remember how to memorize a unit circle. It's kind of weird, but it hasn't failed me once. So let me just let this pop up. All right, cool. If you guys will see here, um, as we are going from 1 to 0 or 0 to 1, you will see that the numerator will often increase depending on whether you're going towards 1 or away from 1. So for example, since sine is the, wait, hold up. Yeah, I think I got that wrong because I think I thought sine was x, but instead I think I got my answer switched up, but it's fine. I'll still explain it. So for sine of pi over 6, we already got established that, um, the angle is 30 degrees because, like, you set it to a denominator of 180, which is like, the angle of the unit circle, well, of that quadrant or that half of the unit circle. And you got like 30 as the numerator for that. So when you got sine of pi over 6, what you're doing is you're looking at the x. I mean, you're looking at the, yeah, you're looking at the, wait, hold on. Yeah, sine of pi over 6, my fault. You're looking at the y. Yeah, you're looking at the y. So essentially, since it's going from 0 to 1 in the y coordinates, and it's the first angle in the quadrant going from the left, well, going to the left, it starts at 1. So instantly you will know that the answer for that will be 1/2 because that's the y coordinate for 30 degrees. X is cosine pi over 6, which is what's it called, square root of 3 over 2, because instead of it going from 0 to 1, it is going from 1 to 0 in the first quadrant. So instead of it going from like 1, 2, 3, and then 0, 1, it's going 3 to 1, 0 to 1, because it's going from 1 to 0. So for cosine pi over 6, it would be square root of 3 over 2. And that's how I got my answers.
Okay.
Like, I'm not sure if like there was like a way to do it in the calculator. I mean, I kind of got confused with all that. So like that's my little way of um doing, trigonometry of stuff like that with the unit circle. Any questions?
Usually you can think as in the unit circle or on a triangle. Okay, that's good. Pretty good.
Oh yeah, definitely. Like with a triangle. Oh wait, did I close out my unit circle? Because I was gonna like show something else, but because you brought up a really good point, like about the what's it called, the triangle. Like if you triangulate each point or if you triangulate each coordinate on a unit circle, you can see what type of what's it called? You can see what type of coordinate you are going to put down depending on like the size of the triangle. Like normally, the what's it called? The pi over 4, the pi over 4 angles or coordinates would be like a right triangle, like a perfect right triangle, and then like the what's it called? The pi over 6 coordinates would be like a acute angle triangle, and then the pi over 3 angles would be like a acute, like an obtuse angle. So yeah, that's what I took away from that homework.
Okay, so pi over 4.
Hello?
So when we
Is
talk
everything
about
good?
the angle, we have 2 units. One unit we use pi. So pi over 4
Yes.
radian equals to 45 degree.
Mm-hmm.
Pi over 6 radian equals
Yes.
30 degree. Yeah, pi over 3 radian equals to 60 degree. You could use both, either unit. You can convert one unit to the other.
Right.
Okay, good. Right, then choose from different homework. This is good.
Oh, can I? Oh, got you.
You know,
Question. Do
let's
you mind if I also bring something up for like the class?
I think
What's up?
right. I think Jeremy wants to show something too, and hopefully Andy can present
I know.
also.
I mean, it's gonna be like really quick. Yeah, guys. It's not gonna be a presentation. I can turn off my screen for this one. It's cool. Um. So yeah. Also, one of the big things about like unit circles and finding like radians from degrees. This is another thing that helped me out. Take the degree and divide it by 180, and just keep like simplifying it from there. But also put like keep your pi in the numerator, so that way eventually once you get to that radian, like that simplified radian, you get the simplified radian that you need to solve the problem. That's what usually helps me out. I didn't put that on my work, and I'm sorry, but like yeah, it's one of my little tools.
Okay.
But yeah, you can go now, Jeremy. I'm sorry if I
No,
under.
it's good. Good. Let's see. So let's see if Jeremy or James. Yeah, let's take turns to present. This is good. You know, it's a good review. Liam, you can keep looking from different homework to present. All right. Also.
Oh yeah. I got another homework I would like to present if that's okay. Homework
Yeah.
9. I haven't done that yet.
Yeah.
All right, let me just take that snapshot as well. I actually like that homework as well because I'm really like big into logarithmic functions and all that. So I'll definitely review that.
But choose from different ones. Choose from maybe from rational functions, from polynomial functions, logarithm functions, exponential functions, trig functions.
Yeah,
So this course is
that's what
basically
I'm
to
picking from.
understand all these basic functions.
Yeah. Homework 9. Cool. Send. All right. It should be coming up now.
Okay.
Lit. All right. Um Again, I apologize if this is kind of wrong. Again, I'm not like a genius, so well, you were warned, I guess. All right, so this is homework 9. And I guess I will be going over numbers 10 and number Yeah, I'll be going over number 10 and number 29 from 4.3. So overall, from the way it looks, basically what the homework was asking us for was to convert the logarithmic function into, the logarithmic form into exponential form. So basically what I usually do is, well, for the first example, we got log of 3, well, I forgot how to pronounce it. Log of 3 of
We read
81
this
equals
way.
4.
Liam, we
What
read
happened?
this way.
Yes.
Log
Yeah.
base 3 of 81.
Thank
Log
you. I almost
base
forgot.
3 of 81.
Yeah,
Okay.
log base of 3 of 81. Thank you. I literally almost forgot. So basically, what I almost like, and thank you for reminding me because I actually brought up my second point. So the way I labeled it, you don't see it on my work because I didn't put it there, but it still applies. Um, the way I go about this is I, label them. So 3 is the B, which is base. Um, 81 is the A, which is adjacent, and 4 is E, which is the potential exponent. And what you want to do is you want to turn it from bay to B, which sounds weird, which is like bay, which is BAE, to B, which is BEA. So what you do is that you take the 3, right? You take the base, you set it as a leading term. You bring the exponent to the left side of the equal sign, giving the exponent, giving 3 the exponent of 4, and then you bring the adjacent to the right side of the equal sign. And it essentially gives you, 3 to the 4th power equals 81. And to test it, literally, that's all you got to do is just like bring 3 to the 4th power and it gives you 81. The second example that we have is log base 3 of 1 equals 0. And that one's pretty simple. That one is actually simpler than the other one, even though they're both pretty, like, simple. Same thing as before. You label it, B A E, which is bay. So you take it from bay, turn it to B, and you get, 3 for your B, O for your E, and 1 for your A. And essentially it just answers its own question. Like, because anything brought to the power of 0 is automatically 1. So it's basically self-explanatory. Yeah, 3 to the power of 0 is 1. And that's like an essential rule that anything that's brought to the power of 0 is essentially 1. So now if we bring it down here, we got now we got what's it called, variables to consider when it comes to logarithmic functions. So now we got log base 2 of x equals 5. So instead of like it as the answer like number 10 did, my fault, it was number 10. We actually have to figure out x is. We actually got to figure out what, the exponential function equals to. So, but that's nothing to sweat over. So all we got to do, we got to convert, like I said, bay to b. You get, 2, you bring it down, make it a leading term, take the 5 on the right side, give it to the 2, give that the exponent, and you bring the x to the right side of the equal sign, and you get 2 to the 5th power equals x. Now, that's just like some simple, like, what's it called? Power function? Yeah, it's power functions, I guess. So, like, from then you got, like, 2, 4, 8, 16, and 32. That's the 5th power of 5. So, instantly you get, like, 32 because 2 to the 5th power equals 32. And for the second, example, we get log base 2 of 16 equals x. And simply all we got to do is convert it to exponential form. We get, 2 of x equals 16. And again, that's another simple, but oh, my fault. This time it's different because now we have to figure out, what the exponent is, which is, it's also pretty simple because, like, all you got to do is just, like, um, radical both sides and see how many see how many times 2 goes into 16 in terms of like powering. And we see that, it goes into 2 it goes into 16 to the power of 4 because, because the fourth power of 2 is 16 because we got 2, which is the first power, 4, which is the second power, 8, which is the third power, and 16, which is the fourth power. So essentially, the answer for that is 4, and then you plug it back in to see if it makes sense, and it does, which is 2 to the fourth power equals 16. So yeah, that is my work.
It's
Any
good.
questions?
Okay, it's good. It's good. It's good. Right.
Thank you.
Okay, thank you.
Would you like to anybody else like to present, or am I all clear? I didn't want to hog the mic.
Okay, let's see. James, do you have you choose one to present?
Yeah, I think so. Yeah.
Okay.
Give me a second. Just give me a second.
Would you like to go after me?
Oh, actually,
James?
Jeremy, you can go first. You can go
Okay.
first.
Okay, thank you so much, James.
Yeah, sure.
All right. So, Dr. Chen, I'm presenting from the review sheet.
Okay, great.
It's with the question on the third page where it says given function f of x negative 4x squared plus 3x plus 1.
Do you have your work? You can share your screen with us.
Yeah, I have it.
Oh, okay.
You see it?
Great. Yeah.
Okay. So that's everything. And basically I did it's the same question, same concept like the one I presented on Friday, but I am aware that I didn't do the x-intercept questions. I just found like the vertex, the roots, and the graph because that's what the question had asked.
Okay.
So yeah, basically I did the vertex formula negative b over 2a, and I plugged in 3, which is negative b because 3 is positive, and since it's negative, and a is negative 4, and this way I got 3 over 8. And then I did the quadratic formula, and eventually I got negative 1 over 4.
What is that? What does the quadratic formula gives to you?
It gave me the roots.
Oh, okay.
4, and yeah.
But maybe you can put x equals to the quadratic formula.
Okay, yeah, my bad. I didn't do that. I didn't
Okay.
put x.
But you have down here, you have roots equals to x equals to negative quarter and the 1.
Yes. And then this is my graph.
Okay. So your roots negative quarter and 1. Your vertex is a 3 over a, and its y value. Okay, looks good.
Yeah.
Looks good. All right. What's your y-intercept? Y-intercept is important to mark. Also, James, once you graph, you can write down your points on the side of the graph. On the side of the graph.
Oh.
On the side. Yeah.
Yeah, my y-intercept, I made the same mistake. I just put 1, but I didn't put 1 and 0.
Hold on 1 second. Which one is 0? Y-intercept is a point.
Yeah, but it's right here. It's 1, but I didn't put 1 comma 0. I just put 1.
It's a 1 comma 0
Yeah,
or 0 comma 1.
1 comma 0.
Can you explain why it's 1 comma 0?
What is it?
Y-intercept.
Also, is it so? Also, it's the other way around.
How do we find the y-intercept?
Oh,
We put the x value is 0, right?
yeah,
So when x equals to 0, we find f of 0. We
yeah,
substitute x into 0.
right.
So we get 1, right? It's the other way around. It's 0 comma
Yeah,
1.
yeah. I keep getting it confused. Sorry.
Yeah, no, it's okay. It's, sometimes we do. Okay. So can you scroll down here? Right. Okay, once we have graph, it's good to mark those important points. So usually we put the points on the side of the vertex. Also, we put the y-intercept. The y-intercept is the important point also. So vertex, y-intercept, and the x-intercepts.
Okay.
We only need those points. We don't really actually need, you see you marked the other 3 points. We don't really need them. We need a vertex, roots. Roots are x-intercepts, then y-intercept. Okay, but this is
Okay.
good work. Okay, this is good work. Thank you, Jeremy.
Yeah, no problem. Thank you.
Okay. Okay, James, are you ready?
Yeah. But I'm not sure if you're going to, accept me doing this, so I'll just show it.
Let's see which one.
Okay. So I'll be doing homework, what's the second? Homework 14. Yeah, homework 14, number 4. And it says here in 5.1, number 4, show that the point is on the unit circle. So to prove that the point is on the unit circle with these 2 points, both should be equal to 1. And we need to use a certain formula, which is x squared plus y squared equal to 1. Right, Professor?
That's right.
Okay. So the easiest part is just, implement these two respectively. So negative 5 over 13 is x squared plus 12 over 13 squared is y squared. So since both denominators are equal, we can just combine these two uh, numbers into one equation. Is that right? Okay. Now we just, well, add these two. First, we square both. So 5 squared plus 12 squared is equal to 169 over 13 squared. Now, what we can do with 169 is make it 13 square so that both the numerator and denominator can be equal to 1. So, therefore, 1 is equal to 1, meaning true. So, these 2 points.
Hello?
Hi, Professor, what happened?
I have no idea. Something's wrong. It's reconnecting. So now we're back.
Wait, so you didn't get any of that?
No, I get it. I said, so in the end, you said it. So that proves that point, right? This point, x value negative 5 over 13, y value 12 over 13, which is on the unit circle, right? Yeah, good. That's good.
Okay.
But what I need is I would need you put a negative 5 square into parentheses. So negative 5 squared. So the negative is also being squared.
Okay,
When
okay.
negative being squared, it become positive. Okay. All right.
Okay,
Good. Good.
thank you.
Choose some different ones.
Okay. Oh, right.
All right. Let's see. Liam, you like to show from other homework as well? For James, also you can choose from different homework to
Yeah,
show.
I'm still finding one. Ugh.
Liam.
I'll present now.
Oh, great. So this Nicola. Yeah, go ahead, Nicola.
So I'm presenting homework 13.
Okay.
Yes, for question 46.
Okay.
2 log x equals to log 2 plus log 3x minus 4. So first I apply the product rule, which is going to be 2 log x equals to log 2 times 3x minus 4, which is going to be log x squared equals to log 6x minus 8. And then I'm going to solve for it. No, after I'm going to put it equals to 0. And then, sorry. And then I'm going to rewrite the 6x, negative 6x, as a 2 and 4 because 6, 2 plus 4 equals 6. So x squared minus 2x minus x plus 8 is equal to 0. And then I'm going to group the terms. So x times x minus 4, negative 2 times x minus 4 is equal to 0. So x minus 4, and then x minus 2 is equal to 0, and then I just solve for them individually, which is going to be x is equal to 4 and x is equal to 2.
Okay, so this is solve logarithm equations, right?
Yes, yes.
So you turn the logarithm equation into a quadratic equation, then you solve it.
Yes.
Okay, all right, good. Good. All right. I guess we'll finish up to here. See you on Friday.
Professor,
Yeah.
can I do one more?
Sure. Which one? From which homework?
Let's go for what's this? Homework 15.5.2, the trigonometric functions, the special ones, the sine times 5 pi over 6.
Oh, I see. Let's go.
Okay. Uh, I hope I get it right. Okay. So for homework 15.5.2, it says find the exact value of the trigonometric function at the given real number. So basically, we're finding the exact value for these three. Oh, I'll be doing number 6, by the way. By using a special table that we needed to learn. So yeah. So for number 6, letter A, sine times. Sorry for the no
Not
parentheses there.
James, not times. This is the sine of an angle. Sine of 5 pi over 6. This is not
Oh,
multiplication. It's just sine, just a symbol.
oh, okay.
Remember, 5 pi over 6 is remember what does sine mean? Sine give us a triangle, right?
All right.
A triangle. Then we focus on one angle. Sine means opposite side divided by the hypotenuse.
Yes. Mm-hmm. Yeah,
Okay,
sorry. So it should be sine angle 5 pi over 6.
that's right.
Oh, okay, okay. Okay, so sine angle 5 pi over 6 will become sine angle pi over 6 by using the reference angle. And the reference angle for 5 pi over 6 is, well, pi over 6. So sine angle uh, pi over 6 is 1/2 because by the special table for these three. The next one is cosine angle 5 pi over 6, as the same as the letter A. It will become cosine angle pi over 6, but this time its exact value would be negative square root of 3 over 2. And for the last one, tangent angle 5 pi over 6, as usual, would become tangent pi angle pi over 6. Its exact value this time would be negative square root of 3 over 3. So, yeah,
Over 2.
over 2?
Over 2, right?
Really?
Yeah. Pi over 6. Oh, hold on. No. Over 3. Over 3. That's tangent value. No, you're right.
Oh, okay, okay.
You're right. Tangent value. Okay, let me ask you very important questions. So
Yes,
how do
sure.
we use reference angle? So let's see the first one, right? Sine 5 pi over 6. So 5
Mm-hmm.
pi over 6 is in which quadrant?
Sine 5 pi over 6.
No, 5 pi over 6. The angle
Oh,
pi over 6.
that would be in, give me a second, Professor. Quadrant 2. Yeah, quadrant 2.
Quadrant 2, right. So in quadrant 2, so we use sine of its reference angle. And
Mm-hmm.
quadrant 2 sine value is positive or negative?
Positive, positive.
Positive. So that's why sine 5 pi over 6 equals to sine pi over 6 equals to half. So the first one is, okay, good. Let's check the second one. So now we know 5 pi over 6 is in the second quadrant. In the
Mm-hmm.
second quadrant, cosine value is positive or negative?
Negative.
Negative. So now you need to write down negative cosine pi over 6. You're missing
Oh,
negative sign in the middle.
oh,
You see,
okay.
because cosine pi over 6 is in the first quadrant. Cosine pi over 6 will be positive square root 3 over 2.
Hmm.
But the 5 pi over 6 is in the second quadrant, and
Yep.
cosine value is negative.
Hmm.
So we would get negative cosine pi over 6.
Hmm.
Make sense? So the middle one, cosine pi over 6, you need to put a negative sign before cosine.
Hmm.
So negative cosine pi over 6.
Oh, okay, okay.
Then your answer is right, negative square root 3 over 2.
Hmm.
So for C, 5 pi over 6 in the second quadrant, tangent value has to be negative or positive.
It's also negative
It's also negative. So you're missing negative sign in
again.
front of tangent pi over 6, right?
Ugh.
So it's just missing 2 negative signs. But your answers are all good. Your answers are right.
Hmm.
Okay, good job.
Okay. So how many presentations do I need left to do, Professor?
Let me
Let's
see.
see.
If you want to get a perfect, you need 3 more presentations, which you can do next class.
Oh, so wait, this doesn't the last one doesn't count?
No, you can't. That's why you have 7 now. You had 6 before.
Oh, okay, okay.
Yeah. So
Oh
today
yeah,
you should, right.
Professor, remember that homework last time I asked for you sent me an email, regarding homework 16.
What's regarding homework 16?
It's like I won't be able to give you full credits for your homework since it contains essential conceptual errors. Remember that day I actually presented that day, but I didn't get a grade on it. I was doing number, what was that?
Oh, you listen to me? Let me see.
Yeah. Yeah,
I don't think I
remember,
received any new ones. Let me check. From James.
yeah, I think I did number, yeah, 57. You know, the tangent t, sine t, then quadrant 4. I never got a grade on that.
You're talking about homework, not 18, right? 18?
No, not 18, number homework 16.
Homework is 16.
This was all about the tangent thing. What was that? Oh, wait.
Oh, you send me new ones?
Oh, where's that? Where's that? No, 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 no.
Can you send to me again? Because I don't remember I received twice of your homework 17.
No, 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 not homework 17. Homework
Uh,
16.
homework 16. Can you find it? Send to me again.
Oh, sure, sure. Okay. So new message. Browse computer. Not 8, 14, or 16.
Okay. Anyone has any questions?
There we go.
Professor, can you tell me how much more presentation?
The color, right? Color, let me see. The color, you have 8.
Yeah.
Oh,
Yeah.
is this the
You
one?
can present
Yeah.
next time also, next class, Friday on Friday.
Okay. And I know I still have to turn in homework 17. I didn't turn it in yet. I just This is because I really have good internet to even connect to the class. So
I see Nicola, right. I
I'll
don't
send
have
it
all
in
of
soon.
the homework yet, but you still have time to catch up with your homework.
Yes, it's only homework 17 because I complete all the other homework, even homework 18. Only homework 17 I haven't turned in yet.
Oh, I see, right. I see homework 18. I'm just missing your 17. Yeah, right.
Professor, I sent it. Yeah.
Okay. Yeah, I just received it.
Where is it?
Let's see 57.
Mm-hmm.
57, right. Your tangent t equals the sine t over square root of 1 minus sine square t, which is positive or negative? Because this angle is in quadrant 4.
Since students take calculus, that's negative.
That's negative. Good. Then tangent t cosine t, tangent t in quadrant 3, which is positive. Okay, you have read tangent t equals to. You see
Oh
50,
crap! I forgot about that.
right? Read tangent t equals to square root of 1 minus cos square t defined divided by cos t. I see. So you make corrections. Tangent t equals a quarter in quadrant 3. What do you have? 68. What do you have to do with 68? I don't remember 68.
Wait, 68.
68, right?
Oh
Tangent
no,
t.
no, no, Professor! Not about the homework itself. It's about the participation grade. Remember on that day you were asked, to us to make us participate. I did number 57, and on that day my grade was still 5/10. I
Oh,
did. Oh, you
oh,
get it now?
Okay, so you're talking about your homework grades, right?
No, not the homework grade, the participation grade.
Or the
Since
participation grade. I see.
I never got a participation grade for number 57, sadly.
I see. You handed up all your homeworks, right?
Yep.
After 18. I see.
Yeah.
I see. Okay, you got it.
Oh, really?
Yeah.
So how many more participations do I need to, to make this grade of mine passable?
Now for next class, try to present 3 more questions.
Oh,
If you could,
okay.
all right. If you could,
Okay.
choose from different homeworks.
Okay, okay.
All right.
Okay, thank you, Professor.
Oh, thank you. Jeremy and Liam, do you guys have questions?
No, thank you.
Okay, Jeremy, right, you're A+. You have I have everything.
Okay, cool.
Okay. And Liam, can you hear me? Liam needs 1 more homework and 5 more presentations.
I think he's doing something else, Professor. I'll just remind him.
Oh, okay. All right. Yeah.
All right. Thank you, Professor.
Okay, thank you. I see you on Friday, all right?
Okay.
So get ready for Friday.
Mm-hmm.
And Jeremy, right, try the review sheet problem also. So get good grades on final.
Yeah.
All right, have a good day. See you on Friday.